welcome dear students. Welcome to nuclear physics lectures. I'm Dr. Pervez Ahmed, and today's lectures we will discuss about nuclear fusion. So let's start a lecture with the nuclear fusions. What is nuclear fusions? What actually happens in nuclear fusions? And nuclear fusions two nuclei with the low mass numbers combined to produce a single nucleus with the higher mass number. So this is a more formal definitions of the nuclear fusions. So in simple words, what actually we mean by nuclear fusions? And in nuclear fusions, we just do what actually we just want to do, or what is the purpose of the basic doing is that we fuse uh, two light mass nuclei. That is, uh, we trying our level best, we trying our efforts to combine two lighter nuclei. The lighter nuclei here we mean just like you can see it here in this nuclear reactions. We're trying to combine or we're trying to fuse deuteriums and tritium nucleus and to a single nucleus, that is helium nucleus, just like you can see it here in this particular reactions. So what actually happened during these fusions, when you want to fuse deuterium with the tritium, so it's been combined, it's been fused into heliums. uh, as a result we get a neutrons and a huge amounts of energy. How basically the fusion happened, so you can see the basic fusion process and these animations. And this animation you can observe the two ball-like structures. This is the first one is the deuterium nucleus, and the second one, I mean the top one is the deuterium nucleus, and the bottom one is the tritium nucleus. So uh, what actually it's happened, or what happened in this process, you have to closely observe the animations. We actually fuse two lighter mass nuclei, that is deuterium and tritium. So what actually happened as a result of that fusions, just like you can see it here in these animations, we get a helium nucleus along with one neutrons and an amount of the energy. So this is the basic process and fusions, nuclear fusion reactions. Let me repeat it again. uh, so what actually happened, uh, nuclear fusions, we have deuteriums and a tritium nucleus. What actually we do, we try to combine these two nucleus that we call fusions. I mean, what actually we do, we trying to fuse these two nuclei. So when once we fuse it into a helium nucleus, so along with that we get a neutron as a result of that nuclear reactions, and with this we get a huge amount of energy. So how the process occur, so that you can observe and the animations. So just like you can see it here in the fusions, the two nuclei, they are being fused. So as a result of that fusions, we get helium nucleus along with the neutron and energy. So this is how the fusion reactions take place. Uh, just like you have people have observed the energy from the fission, so similarly you can observe or you can calculate the energy from the fusion. So how we get or how we can calculate the energy from the fusions, let's see the reactions. I mean, this is the basic nuclear reactions which happen during the fission, during the fusions of deuteriums and tritium nucleus. You can see it here. We combine or we fuse deuterium and tritium and to a helium nucleus. As a result, we get, I mean, along with the helium's nucleus, we get a neutron and energy. So how we calculate the energy? So first of all, you know about the atomic masses on the reactant side and on the product side. So on the reactant side, we have the deuterium and tritium. So the mass of the deuterium is 3.345 10 raised to power minus 27 kg. Similarly, the mass of the tritium is 5.008 and 10 raised to power minus 27. On the product side, we have helium nucleus. So the mass of the helium is 6.647 in 10 raised to power minus 27 kg. And we have a neutrons, and the mass of the neutron is 1.6750 in 10 raised to power minus 27 kg. So how we do the calculations? So calculate the following. That is, we have to calculate the mass difference, uh, the energy. Then we can get from the mass difference, we can get the energy release for fusions. So that's how we calculate the energy from the fusions. So again, you have to look upon the reaction, the basic fusion reactions, and from that you have to calculate the total mass before the fusions. That is left hand side of these equations, which is this equation. The left hand side we have deuteriums and we have tritium. So first you need to calculate the total mass before the fusions, which is, I mean, you have to add up these masses. That is, you have to add the mass of the deuteriums and the mass of the tritiums, which we I mean, by adding the mass we get that is equal to 8.353 into 10 raised to power minus 27 kg. I mean, this is the combined mass of deuterium and tritium. Similarly, the mass on the right hand side of the equations, uh, the total mass after fusion, I mean, by mistake it's being written fission. Be remember, this is not fission. This is basically fusion reactions. So the total mass after fusion, that is on right hand side of the equations. So what is that? The mass of the product, that is the mass, the total mass on the right hand side of the above equation, when you add up, so you get it equal to 8.322 and you 10 raised to power minus 27 kg. So now you have to find out the difference. That is the mass m is equal to total mass before the fusions. I mean, this is the formula, that is the formula we utilize in fission reaction. So just like that, we can utilize this formula for calculating the total energy and the fusion as well. I mean, the formula we applied, that first of all we find the mass difference, that is the mass before fission and after fissions. So the same concept you can utilize here. So what actually you do, you calculate total mass, you calculate total mass before the fusions, and then the total mass after the fusions, and then you find out the difference, and the difference then you multiply with the c square, the value of the c square. So how you do that? I mean, here if you can fuse with the fission. So actually we are utilizing the same concept, concept of that of fissions. So here we mean it's not fission, it's between the fusions. But the concept is that, I mean, the old concept we are utilizing here, that of the fission reactions. I mean, the concept utilized for calculation of energy in case of fission reaction. So the concept is old, but here by fission we means a total mass before fusions. So total mass before the fusion is the 8.353 into 10 raised to power minus 27, and the total mass after the fusion is equal to 8.322 into 10 raised to power minus 27. So you get the mass difference. So the mass difference come out into 3. 3.1 and 10 raised to power minus 27 kg. This is the mass difference. Uh, so what actually you do with the mass difference? I mean, you get this mass difference. That is the mass difference between the reactant and the product. So what actually you do, you know the mass, you know that the value of the C, that is speed of light, is equal to 3 into 10 raised to power 8 meter per second. What is actually mean E, that is the energy. So energy by Einstein, most famous relations, mass energy relations, is equal to mc square. So what you need to do, you just put the values in these particular equations. That is, you put the values for the m, that is the mass difference, and in the value of the c square. So after that, you just do the calculation with the help of the calculators. So you get the values of energy is equal to 2.79 into 10 raised to power minus 12 joule. So this is the amount of the energy you get from the fusions of the deuterium and tritium nucleus. I mean, when you combine these two light nuclei, so this much of the energy is released during the fusion of these two lighter nuclei. I mean, in other words, you can say that this much, that is 2.79 to 10 raised to power minus 12 joule of the energy released for fusion. I mean, this is the energy release for fusions. I mean, someone asks you what is the energy for fusions. So the energy release for fusion is 2.79 in 10 raised to power minus 12 joule. So that's the energy from the fusion. So that's all we have for the nuclear fusion reactions. Thanks for watching. See you in next lecture. Till then, bye bye.